Hello everyone, this is Venkat from Arima Labs. I'm back with another episode of Ask MMGPT. Last week we saw how multicollinearity could be an issue for MMM. One of the solutions for multicollinearity is regularization, but regularization comes with its own pros and cons. Let's see what MMGPT has to say. So we saw that in the context of MM, regularization has its own pros and cons. But what does the word regularization mean? What are we trying to regularize? Well, to explain it in a more elaborate fashion, through regularization, we are trying to control the coefficients. We are trying to control the value of the coefficients in a linear regression setting. Regularization is an umbrella term. It connotes lasso, ridge, and also elastic net. Typically, regularization is used for two reasons. One is you're trying to, strike a balance between bias and variance in the model, and second, you're trying to build a more parsimonious model. So you might be wondering, how does regularization mitigate multicollinearity? But just to make things clear, regularization does not eliminate multicollinearity. It mitigates the effect of multicollinearity. One of the effects of multicollinearity is inflated variance. You must have heard of the test like VIF, which stands for variation inflation factor. Whenever you have a multicollinearity in the model, it means that some of your coefficients could be highly inflated. The variance of the coefficients could be highly inflated, and that is what we are trying to gauge through tests like VIF. Now, through regularization, you have reduced the variance in the model. But as you recollect, there is always a trade-off between bias and variance. You might have reduced the variance, but it comes at the cost of increasing the bias in the model. And this is where things become really problematic for MMM. Higher bias is always problematic for MMM. Higher bias means that you're always straying away from the ground truth. So in MM setting, which is all about identifying the true effect of your marketing variables, the true attribution is never really achieved because you're almost always straying away from the ground truth. You might have reduced the variance in the model, but at the end of the day, you're ending up with a model which is having a higher bias, which means you have not identified the effect of each individual marketing channel accurately. And this is the reason why regularization is not a foolproof method to overcome multicollinearity. There's a saying that the cure must not be worse than the disease. In this case, regularization is a classic example where the cure is unfortunately worse than the effect of multicollinearity. In the future episodes, we'll cover how we at Arima Labs overcome the problem of multicollinearity without using regularization. Until then, goodbye from me. And if you like to get more accurate insights on MM, please subscribe to MMGPT. Thank you.